Hello, and welcome to the Mind-Body-God Connection. Imagine this. You're just 10 years old. You're dressed and ready for school. And suddenly, there is a powerful explosion, a fire in your house. Well, this is what happened to me. My brother and my sister and I, we had just finished breakfast and had a little time on our hands before being picked up for school. I was the 10-year-old. My sister was 9 and my brother was 7. Well, we sat down in front of the wood-burning stove. We lived with my grandmother, and she had this old-timey stove that would heat up the whole house. And we really needed that stove that day because it was freezing. I mean, it was cold. And my brother and sister were a little bored, so they decided to play a game. They put the kerosene can on top of the hot stove. They then decided to shoot arrows at the stove. They wanted to see who could knock the can off of the stove. Well, needless to say, we did not make it to school that day because there was a powerful explosion. Fire was just beating all up the ceiling, on the walls, and I remember this event like it was yesterday. I went yelling and screaming through the house. The house is on fire! The house is on fire! The house is on fire! Well, fortunately, my father was there and he was able to put the fire out. Now the fire was out, but I continued to run around the house shouting that the house was on fire. My father had to catch me to calm me down. I was an emotional wreck, and I'm sure that I was near exhaustion. Now, this event happened decades ago, but I can retrieve the memory just like it was yesterday. How does this happen? How are memories made? How are they retained? And where are they stored? What about our emotions? Now, I can laugh today, but back then it was not funny. And how can I recreate this story to tell you? This is what we're going to talk about: our thoughts, our memories, and emotions. Now, think about this. Every day, we come into contact with tons of information. Every day, there's something coming at us. And it is impossible to remember every event. Can you imagine recalling every experience in your life? Trying to remember everything that happens in a day? Now, I can use a better memory, but I don't want to remember everything. Every name, every telephone number, every street address, and every item that you bought at the grocery store and how much you paid for it. Now, what about college and high school? Do you want to remember everything from way back then? And every emotion that you experienced with all of those experiences? This type of information would overwhelm the brain. It would cause sensory overload. David said in the Psalms that we are fearfully and wonderfully made. Our brain, which is only 3 pounds, is 2% of the body's total weight. But the brain is hungry. It has a voracious appetite. It consumes 25% of the body's total energy. It takes a lot of energy to keep the brain running. And it is unlike any other organ in the body. It is constantly in action. It never rests. Even when we are sleeping, the brain is working. As a matter of fact, some of our best ideas and discoveries occur while we are sleeping. You know, you hear about people who wake up in the middle of the night and they have a brilliant idea. Well, the brain never rests. And with all of this work, it runs on 12 watts, the power of a refrigerator light bulb. It is impossible for the brain to store every event. The brain is smart. It selects what is important, and those moment-by-moment experiences that we come in contact with every day, they just go into a black hole. Now, how did I recall this childhood fire? I can actually see the fire right now as I'm talking to you. I can see the flames as they were beating up the ceiling and the wall. Remember in our last lecture, we talked about the 4 lobes of the brain, the frontal, parietal, temporal, and occipital lobe? That mental image of the fire is captured on the nerve cells for the sight of vision in the occipital lobe. The words, "the house is on fire," that's registered in the temporal lobe of my brain. This is where hearing and language comprehension takes place. And the parietal lobe, it's the brain's GPS, the site of sensory information and perception. It's like a map which helps us to navigate through life. You look at a taxi driver and he's able to cruise through a large city because he has a mental map in his mind, and it is the parietal lobe. And of course, the amygdala. It's the emotional part of the brain, the site that logs in fear. Now, memories from that childhood fire are stored all over my brain. Little fragments of the sight, the sound, the emotions, and they're all pulled together by an area in the brain called the hippocampus. So, how does this happen? Well, in order to see how this occurs, we need to look at the anatomy of the brain. The nerve cells. We have 100 billion nerve cells. They are the building blocks for the structure of the brain. Every thought, memory, and emotion is housed on our nerve cells. And then there are synapses, little junctions which connect one nerve cell to another. And the brain has 100 trillion synapses. The brain is like a superhighway, tons of information that are housed on the nerve cells which gather and send information throughout the brain and the body. Each nerve cell consists of 3 parts, a dendrite, a cell body, and an axon. And what is interesting is that a nerve cell has a striking resemblance to a tree. It looks like a tree. Our thoughts are hanging out on trees. In fact, the word dendrite means tree. It is here on the nerve cells that electrical impulses are generated and then carried across by chemical messengers called neurotransmitters. There is no way that we can remember everything. Most of what we see, what we hear, what we smell, taste, or touch, most of our experiences are not registered. However, a few events are so strongly registered on nerve cells that they leave deep impressions, pathways, which alter the structure of the brain. These impressions are so striking that they cause new connections to form between nerve cells. For instance, let's say you see something that is highly unusual. For example, maybe you are at the zoo. You've never been to the zoo, but you've seen pictures of zoo animals on TV. You've seen animals in magazines. So this is not entirely a novel experience for the brain. But what is unusual is that while visiting the zoo, you see a monkey that is smoking a cigarette. He is puffing, making halos, and he's actually holding the cigarette between 2 fingers. And the brain is saying, wow, I've never seen that before. Well, this rather striking event causes a strong electrical impulse to fire down your nerve cells. And the cells are so excited that they form connections with other nerve cells because of the uniqueness of the experience. But wait a minute, a monkey smoking? How does a monkey learn to smoke? Well, hold that thought in your short-term memory and we'll come back. Now back to the childhood fire. The reason I can recall this decades later is that it was an emotionally charged event. It is encoded in what is called flashbulb memory. These type of memories leave vivid pictures in the mind. It's like a snapshot of who, what, when, where, and how. Well, not how, but where. These flashbulb memories are laid down during emotionally charged events. For instance, I remember exactly where I was on September the 11th, 2001. This event was an emotionally charged experience. Now, if you ask me what happened the day before September the 11th or the day after, I can't tell you. But that day caused my attention to be grabbed, and this event is permanently stored on my brain cells. Now, we all have emotionally charged events, memories in our minds, the death of a famous person, a horrific national disaster, and we all have personal events that have happened to us. Dr. Eric Kandel is a psychiatrist and neuroscientist, and in the year 2000, he won the Nobel Prize for his research in how memory is stored and how it is formed. He was able to demonstrate the molecular basis of memory and show that long-term memory is the result of several factors. Now, bear with me because this is a mouthful. He said that it is the result of neurotransmitters, protein kinase, ion channels, and transcription factors called CREB, in which their proteins bind with DNA. These events cause certain genes within the nucleus of the cell to switch on and others to switch off. And this process initiates the growth of new connections and cause memory to become stabilized. Now, we have many types of memories, but they fall into just two categories: short-term memory, which lasts from minutes to hours, and long-term memories that last from days to weeks to years. But most long-term memories are not stored as highly charged emotional events. In general, long-term memories require repeated exposure, spaced training with intervals of rest. So you can't go over something just once if you want to learn it. You have to make that memory solidated in your mind. You have to keep firing that neuron over and over again until it becomes permanently stored in your brain, unless it is an emotionally charged event. Now, let's go back to the smoking monkey. That information is stored in your short-term memory. Right now, in real time, it is housed on the nerve cells in the front part of the brain, the prefrontal lobe. Now, let me ask you a question. Have you ever heard the saying, monkey see, monkey do? If so, you just plugged into your long-term memory, the hippocampus. Now, do monkeys smoke? Well, apparently one did. Charlie. He was known as the smoking chimpanzee. But how did Charlie learn to smoke? Well, Charlie saw people smoking, and he mirrored exactly what he saw. He would put two fingers together with one hand, and with the other, he would bomb cigarettes, and he had an endless supply. Charlie was hooked on the nicotine. In 1995, a group of researchers discovered what is now known as mirror neurons, and it was an accidental discovery. They were observing brain activity in monkeys, looking for specific behaviors. And this is what they did. They put a row of peanuts in front of the monkey. And every time the monkey would reach out for a nut, a certain area in the brain lit up and it made a crackling sound. Whenever our nerve cells fire, it makes this crackling sound. Well, they repeated this over and over again, and it was no big deal. They put the nuts out, the monkey's brain lit up, and then the crackling sound. But what was not expected was the fact that when the researcher picked up the nut himself, the same area in the monkey's brain lit up, and it made that same crackling sound just by observation. They could not believe what happened. This suggests that the monkey's brain could not tell the difference between seeing something and doing it. These are called mirror neurons. Now, this says that we can watch someone do something and it is as if we're actually doing it ourselves. This is true in humans. So far, researchers have discovered 2 areas in the brain that contain mirror neurons, areas in the frontal lobe of the brain and in the parietal lobe. We unconsciously mimic the actions of others. What we see, hear, taste, or when we smell something that is offensive, we become disgusted. There's an area in the brain that registers disgust, and it's called the insula. Researchers did an experiment. They got a group of volunteers together and they tested their insula. They gave these volunteers a disgusting odor to smell. And then they wired their brains to see what would happen when they observed others smelling the same scent. So the volunteers watched a movie. They watched a movie of people smelling the same odor. And guess what? Their brains lit up as if they were actually smelling the scent. Now, we all have experienced this in some form. Let's say a spider is crawling on someone's arm. And what do? We start brushing our arm. We are mirroring, mimicking those sensations. Emotions. Emotions are contagious. We feel pain when someone else is in pain. You know, someone's crying. You empathize with that person. And sports. We see it all the time in sports. You know, we act as if we are actually playing in the game. The emotions are high, the adrenaline is pumping, and the brain cannot tell the difference between seeing something and actually doing it. Now, this has far-reaching implications, social, moral, and spiritual. We are bombarded with messages from TV, from magazines, and billboards. Are we imitating what we see? In Hollywood, there's a saying, lights, camera, action. They know the elements which appeal to our senses. The sight, the sound, the emotions that we see lights up our nerve cells, generating electrical currents and causing the release of chemicals that move us to action. The Bible says, by beholding, we become changed. You know, the average child watches 4 hours of TV every day, and most of those programs are violent. By the age of 18, that child would have seen 16,000 simulated murders and over 200,000 acts of violence. Are we becoming changed? Let's take a look at emotions. We have 7 basic emotions. They're sadness, anger, surprise, happiness, fear, contempt, and disgust. It is in the limbic system that the emotions are created. And It consists of many structures: the hippocampus, the thalamus, the hypothalamus, the cingulate cortex, olfactory bulb, the septum, and the amygdala. The one that stands out the most is the amygdala. It is going to let you know what is going on, and it is known to be activated during the fear response. Now, each emotion has a specific chemical reaction that corresponds to the feelings that we have. For example, we have different types of tears. We have tears of sadness and we have tears of joy. And we also have tears that come from irritants like onions. And then there are those tears that moisten our eyes. Dr. William Frey is a biologist, and he analyzed two types of tears: emotional tears from a negative charged, stressful event, and then he compared it to tears from irritants. This is what he found. He showed that emotional tears produce a higher concentration of ACTH, that is the stress hormone, and also of the painkiller called enkephalins. God is so wonderful. He knows that in this life we will have pain, and He has programmed into our bodies a way to relieve stress through our tears. Now, we have hundreds of types of chemicals. We have serotonin, which helps to regulate our mood. When we are in a state of happiness, our serotonin levels are high. When we're depressed, we have low levels of serotonin. We also have epinephrine that's involved in the stress response, dopamine, which causes us to feel pleasure. Then there's glutamate that excites the nerve cells to fire, and then GABA, which inhibits the nerve cells from firing. These neurotransmitters are sent throughout the body and brain to help us cope with the demands of the body. So what about our thoughts? Where do they come from? We have 100 billion nerve cells making 100 trillion connections, and they are carried along by electrical impulses, and the thoughts are held together by chemical glue. But where does that original thought come from? Well, we don't know. Science has not been able to figure this one out. But what we do know is that our experiences from the outside world come in on our nerve cells, and it gives us a picture of what is going on. But that initial thought, we don't know where it comes from. Now, when we try to think about the origin of our thoughts, it's like trying to discuss how God created the universe. Now, we see the evidence of the universe, but how He created it, we don't know. Science cannot explain the origin of this. They can't. But the Bible, it gives us insight into what we should be thinking. In Philippians 4:8, Scripture says, "Finally, brethren, whatsoever things are true, whatsoever things are honest, whatsoever things are just, whatsoever things are pure, whatsoever things are lovely, whatsoever things are of good report, if there be any praise, and if there be any virtue, we need to think on these things." These are the thoughts that we should be feasting on, and by beholding, we become changed. Science is now validating what the Bible said thousands of years ago. For as a man thinketh in his heart, so is he. The science is showing that thoughts are biological processes, and by beholding, thinking, feeling, we become changed. God has given us a precious gift, the human brain. And it is with our brain that we are able to generate thoughts and create memories and feel emotions. It is also with the human brain that our humanity meets with divinity. And when we surrender to Him, He submerges His thoughts with ours. Now, that is an exalted privilege to know that the Creator God can live in us and to give us His thoughts. I encourage you to take a challenge. Allow Him, the Creator God, to write His thoughts, His emotions, and His character on the pathway of your nerve cells. It is true, by beholding, we actually become changed. As I said earlier, the average child watches, by the age of 18, 16,000 simulated murders and over 200,000 violent acts. What are we writing on our pathways? By beholding, we are actually changed. In Philippians 2:5, the Bible tells us that we should have the mind of Christ. It says, "Let this mind be in you, which was in Christ Jesus." When we contemplate upon His Word, when we sing songs, when we talk of pleasant opportunities that are encouraging each other, we are writing new pathways in our brain. Until next time, I want you to remember that it is in Him, the Creator God, that we live, we move, and have our entire being. Let His mind be in you. Have the mind of Christ. Thank you, and I see you next time.
Is there a connection between what we think and how we feel? Does the mind talk to the body and the body to the mind? Does this communication affect our spiritual walk? In her new book, Mind, Body, God Connection, Darlene D. Hall explores the links between the mind and the body and its development of disease. Mind, Body, God Connection is available at Barnes & Noble, on Amazon.com, and Christian bookstores nationwide. Mind, Body, God Connection by Darlene D. Hall.